This video is about application of logarithm functions. Password entropy is a measure of predictability of a computer password. The higher the entropy, the more difficult it is to guess the password. The relationship between the password entropy P measured in bits and the number of guesses G required to decode the password is given by this function. Calculate the value of P for a password that takes 5,000 guesses to decode. 5,000 guesses. Let's go back to this function. G is number of guesses. P is the relationship between the password entropy. So this 5,000 guesses is G. Then we do the substitution for this equation. 0.406p equals log base 10 of 5,000 by solver. Control menu, clear the history. Let's type the equation first. Log, you will do control 10 to the x power. Base is 10 of 5,000. Then control menu, enter, enter, enter. Answer is 9.11 at the 3 sig fix. P equals 9.11. B, write down G as a function of P. In other words, you need to change this log into exponential function. We do know the inverse function of a logarithm function is exponential function. So when we have log base 10 of x equals c, we will put base 10 both sides. Then we can cancel. We got x equals 10 to the 6th power. Another logarithm function we will use a lot is a natural log. Natural log of x equals d. We do know natural log of x equals log base e of x. So we will add e as base both sides. X equals e to the dth power. For this function, 0.406p equals log base 10 of g. We will add 10 as a base both sides. Then cancel. We got g equals 10 to the 0.406p power. This is the function we are looking for. Let's go to C. Find the number of guesses required to decode a password that has an entropy of 28 bits, which means P equals 28. Write your answer in the form of this. Since we already got the function for G, we will just plug in P equals 28 into this function. So we got G equals 10 to the 0.406 times 28th power equals 10 to the 0.406 times 28. Enter. 2.33 times 10 to the 11th power. If you are not sure this equation is right or wrong, you can directly use this function. We will substitute p equals 28 into this original function. We got 0.406 times 28 equals common log base 10 of g. First of all, we need to type in the equation. Control 10 to the x power to get log base 10 of g. Control menu, enter, enter, enter. You could see domain error. In this case, you need to put a value for lower bound and upper bound. Go up, enter. Delete extra stuff. Only leave the equation. Control menu. Lower, we will put in 0. Upper, let's do 10 to the 100 power. Just put the big number here. Then enter, enter. We got the solution. 2.33 times 10 to the 11th power. By solver, g equals 2.33 times 10 to the 11th power. Let's go to last one. There is a point on the graph of a function g of p with the coordinates 0, 1. So p equals 0 and g equals 1. Explain what these coordinate values mean in the context of the computer passwords. P is password entropy. D is the number of guesses to decode the password. When you answer this question, you have to write down the entropy is 0 and the number of guesses is 1 to decode the password. When entropy of the password is 0, only one guess can decode the password, which means your password is very weak. Stars are classified by their brightness. The brightest stars in the sky have a magnitude of 1. The magnitude m of another star can be modeled as a function of its brightness b relative to a star of magnitude 1, as shown by the following equations. The star called Acubens has a brightness of 0.0525. Find the magnitude of Acubens. We know b means the brightness. M is the magnitude. We are given brightness 0.0525, which means b equals 0.0525. So you need to do the substitution. M equals 1 minus 2.5 log base 10 of 0.0525. Go to calculator. 4.20 as a 3-sig fix. Or you can write down the whole thing, put the ... as a full answer. M equals 4.20. The series has a magnitude of 7 and is the least bright star visible without magnification. Find the brightness of series. Magnitude of 7 means this m equals 7. So we will Substitute m equals 7 into this function. We will get 7 equals 1 minus 2.5 log base 10 of b. Let's go to solver. Control menu, clear the history. 7 equals 1 minus 2.5 times Control 10 to the x power. Let's go to log base 10 of b. Control menu, enter, enter, enter. We won't get this answer. They said domain error. For the log, we know this b must be positive number. Let's retype this equation. Control menu, enter, enter. Make sure for log equation, for lower bound, you always put the 0. For upper bound, you can put the 10 to the 100 power. Enter. We got the solution. B equals 0.003981 ... or 0.00398. Let's go to C. Find how many times brighter occupants is compared to series. How many times means we need to do the division. The brightness of occupants is given 0.0525. The brightness of series is here, 0.00398. Control divide 0.0525 over. Try to put accurate answer. We will do 0.00391 from previous calculation. Enter. 13.2 as a 3 sig fix. Answer is 13.2.